Okay, here we go. Group meeting October 8th.
Okay, is it my turn?
Yep, you're number 4.
Okay.
So just read that above caption and read number 4 then.
Okay. Suppose pair computing sold an average of a population mean of 45 P phones per minute in 2011. Yes, that means they sold 23 that number P phones in 2011. Yeah, with a standard deviation of 10. And they looked at their P phone sales data and they determined that they are normally distributed. All right, number 4, sample of sizes n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of the sample mean?
So,
Normal?
would you say it's normal, everyone?
Yeah, because it's from a normally distributed
Exactly. That's what I feel.
data.
I concur with that.
What is?
Okay. Cool. Hannah?
Okay, so 5. Samples of size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of the mean Rx? So that one's normal too.
Normal.
Large sample size and it's normally distributed.
Yeah, I concur. All right, and then Lori, number 6.
A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x less than 40? Fine, and I found z, so the z-score.
Mm-hmm.
So I took 40, which is the mu, and sigma is 10, so took z equals 40 minus 45 over 10 divided by the square root of 4, and I got the answer of -1.
Yeah,
and then I
that's what I got too.
Then I plugged it in the applet. I plugged -1 in the applet, and it's x is less than 40, so you do the area that's less than -1, and it's 0.158.
Yeah! Go, Lori. Go, Lori. Go, Lori. All right, awesome. Okay, that's what I got too. Is that the same for everyone else?
Yeah. What I can get.
Okay. Cool. Okay, is everyone ready to move on to number 7?
Yes.
I see Hannah going like this, so I'm going to say that's a yes. Okay. Yeah, like that. Okay. All right, so number 7, a sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 35 and less than 55? So we'll need to do the z-score for both of those. Where's my pen? That's 30 minus 45, which equals 10 divided by...
To do this, how would you start? You'd have to get them separately, of course. But how would you do that exactly again?
So you'd first start out by finding the z-score with both of them, with having 35 minus 45 divided by 10 divided by the square root of 4. And then you'd have that z-score. And then you would find 55 minus 45 divided by 10 divided by the square root of 4 equals that z-score. And then you would type them into the applet and figure out, so it says something that's greater than 35 and less than 55. So you'd find that inner space.
Okay.
On the applet. Yeah, so 10 is the 10 divided by 4.
That is actually our 95, 90, 68, 95, 97 rule.
Is it? So then it would be 95% is in between 35 and 55?
Yes.
Or would it be?
Oh yeah, I remember that on the practice one.
Okay, would it be 1 standard deviation or would it be 2 standard deviations?
I put it was 2. Because negative 10 divided by 5 is negative 2. And 10 divided by 5 equals 2.
Woo! I'll go with that. So it's 95% is in between 35 and 55.
Okay.
Okay, I like that. All right, and then Brianna, do you want to do number 8?
Sure. A sample size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that x is greater than 41 and less than 49?
Okay. Okay.
Let's see here.
What?
Is that the same thing, the 60, 68, 95 rule?
I think it might be, actually, yeah. I'm still working on it.
Okay. Let's see.
I just realized I did the wrong problem.
Oh.
Yeah. Okay. Yep, it would be that. So it'd be like. So did you guys get it 0.95 for that one, for number 8?
That's what I was thinking.
Yeah.
Yeah. That's what I think it is too. I think you're right. Is everyone good? Do we want to move on to number 9 then?
Yes.
Okay, Hannah.
Okay, a sample of size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is greater than 50?
Okay.
Okay, that's when we do this. 50 Did you guys get a z-score of 2?
I got 2.5.
Yeah, I got 2.5 too.
Okay.
2.5 also. There we go.
Okay. Oh, okay. I see what I did wrong.
Okay, I got an answer. Does someone else have one?
Yeah, I got .0062.
Yes.
So 0.62%. That's awesome.
Yes.
All right. Everyone concur? Is that good? Any
Yes.
questions?
No.
We're good. All right. Lori, do you want to do number 10?
Pair Computing sold an average of mu equals 40 p phones per minute in 2010 with the standard deviation of sigma 12 equals 12, and they looked at their phone data, sales data, and determined that the distribution is right skewed. Number 10, samples of size n equals 4 are taken from the right skewed 2010 p phone sales data. What is the shape of the distribution of x? And I put right skewed.
I did too.
I concur.
All right.
All right. Let's move on to number 11. Okay. Sample of size n equals 40 are taken from the right skewed 2010 p phone sales data. What is the shape of the distribution of x bar? I said normal.
Yes.
Oh, what is this? Normal.
Okay. And then Brianna, number 12.
Is there a theorem that justifies your answer number 11? What's the name of it? I think we all know.
What is it?
Central limit theorem, right?
Good.
Okay.
Yeah. That was the one I couldn't remember last week, and Lori was like, bam, there it is. And I was like, ooh.
Yeah. We all have something to contribute.
All right, next one, 13. Hannah.
Okay. A sample of size n equals 4 is taken from the right skewed 2010 p phone sales data, and you want to know the probability that the observed x bar is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why?
Yes.
You can't, because it's not a normal distribution, right?
Yes.
Yeah.
Because it's right
That's
skewed.
awesome, Hannah.
Yeah, because it's right skewed, and then it doesn't. The central limit theorem doesn't apply to it. So. Let's see.
So, okay. I'm typing it. Okay. Since we're good with that one, I actually thought it was can at first, so I'm really bad. So it's good you guys helped me out with
You
that.
thought it was what?
I thought it was, I was like, oh yeah, you can do it.
That's what it usually is like. You get in the habit of it.
Yeah. All right, Lori, do you want to read number 14?
A sample size of n equals 36 is taken from the right skewed 2010 p phone sales data. What is the probability that the observed x is greater than 36.5?
Okay.
I put x is greater than 36.5, and then I went looking for the z-score, which is 36 minus 5. 36.5 minus 40 over 12 divided by square root of 36, and that equals negative 1.75. And then you look for it in your applet, and you find it's 0.959.
Okay.
Correct?
Yes.
Yes.
All right. I'm just writing that down right now.
Me too.
Yeah. Alright. Ah. Okay. Okay.
So what
and then
was the
I'll go
answer
to-
again? Did you say 1.75?
Negative 1.75.
Okay. Oh, I
was
got it
the
that time.
the z-score, right? So then the probability was 95.9599, right?
Yes.
For it being greater.
Yes.
Perfect. Okay, I do understand it. Yes. Okay. So number 15, if you guys are ready for that. A sample size of n equals 36 is taken from the right skew 2010 PFON sales data. What is the probability that the observed mean is between 37.5 and 42.5? So,
So you're looking for z-scores.
yeah.
37.
Okay. Okay, let me know when you guys have an answer.
Okay.
Okay. I'm good.
Okay.
I have it.
Okay, so the answer I got was 0.7887. And I got the z-scores for both of them were negative 1.25 and the other one was 1.25.
Good.
All right? Awesome. All
Wait,
right.
what was the probability? So you add, because I can't get the probabilities, so
Oh, it's 0.7887. So 78%. 78.8.
and that's when you took you just added them together, right? So you like, how do I explain? You did that by hitting the tail ends between at the each negative 1 point. What you did?
Um,
Yeah, I know what you're saying. Yeah, it's just shaded the middle part on the applet.
Oh, you just. Oh, yeah. Okay, that's one way to do it too.
That's
Sorry,
what I do.
I'm following blindly right now.
you're good. We're here. We got it.
Okay.
All right.
Thank you.
Do you guys feel like you're ready to take the quiz, or do you have any other questions from like the beginning of the homework? Whether it be like number one, what were the two conditions must be satisfied in order for a sample mean to be normally distributed? We all got that, right?
Yeah.
Okay, yeah. I didn't know. Do you guys have any questions? No, and we can.
I'm good to go.
So, yeah, I'm pretty good.
You're good. Nora,
Yeah.
you seem good too. Seem great. Okay.
Mhm.
So, all right, guys, let's do this group meeting. Quiz.
Okay.
Let's do it.
Oh, hang on, I gotta log back in. Just a
I
second.
know mine kicked me off too.
Been taking too long.
All right. I'm gonna start mine.
Yes.
Okay. Oh. Okay. So, who just read the last question? Sorry, guys.
I don't remember.
I don't either. It might have. Hold on, I can look.
On the homework?
On the homework, so we can
Yeah.
go from there. Oh, so let's go back to you, Brianna. There we go for reading
Okay.
TV quiz. There we go. I just
Okay.
need to know who to push for.
Okay. All right. So start number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of 1.358 and to the left of negative 3.58, and then round it to 3 decimal places.
Okay.
Sorry, I can't do that one.
Oh no, you're good.
Okay.
So I got
So-
0.175.
You got what
0.175?
for the probability?
Yeah. Do we put this score as 1.358?
Oh,
Mhm.
hold on. 0.17 or 0.175. Okay, yep. I was like doing just the in between at first, and then I filled them. That's good. Yeah, 0.175 is what I got too. And then Hannah, number 4.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in the sample.
Okay.
Okay.
177.6 minus.
So guys, question.
Yes.
Would you take 177.6 pounds and minus it from 185?
That's what I'm doing.
Yeah, 177.6 minus 185.
That's what I was
Okay.
wondering too, though.
That's what I needed to clarify because I was like, wait a second. Both of them are means.
I know.
Okay.
That's me too.
Okay.
And then, let's see. You divide that by 27, right? And then square root.
Did you get a standard deviation? I mean, a z-score of negative 3.468?
Let me see. No.
I got something a little bit different.
I haven't gotten mine yet. Hang on just a second.
I'm confused.
What did you guys get?
So the z-score I got was negative 1.92.
Okay, that's what I got.
Okay. Because like I was thinking, Lori, that yours sounds right though because they're talking about extremes. You know what I mean?
Yeah, but then I got a different amount the second time.
Or you did it? Okay. I don't know. So then,
What did you guys get?
Negative 1.92.
That's what I got. I got negative 1.92.
okay. And then it describes at the bottom of the question that it says, note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours is in the positive direction.
Okay.
So it's like the two flanks, the two sides of the graph is what they're looking at, I guess.
Mhm.
Yeah. I got like 0.0547 if anyone else got that. I don't know.
Yes.
Yes? Okay.
You got 0.0547.
Yeah, and I'll round it to 0.055 because of the decimal,
Okay.
you know. Okay. So then we're good with that one. Then Lori, if you want to do the next one for number
Which of the following will have a smaller standard deviation if non-observations are randomly drawn from a population? The distribution of the individual observation, X. The distribution of the sample means X bar. This cannot be determined from the information given.
Wouldn't it be the sample means? Because there's, like, the more observations you have, the closer your standard. I don't know.
That's true. Yeah. Yeah, I remember that one. Because it did say. Wait a second. I'm trying to think of this.
Smaller standard deviation.
I don't know.
It was the. Let me think before I say something stupid. Okay.
You're good.
Hi, Mom. Oh, thank you. That looks really good. Almost done. I will.
Population drawn from the population.
Food.
Is that why?
I'm doing a group meeting right now.
Okay. So
I don't know. I would think it could not be determined.
that's what I'm thinking, but I don't know.
We only have 9 observations or randomly. I don't know.
I remember when I read on Monday,
Mm-hmm.
it says, I could be wrong, that the sample standard deviation would be smaller. I don't know about the distribution of the sample means because I'm trying to remember, but I just can't exactly remember it. So I'm leaning between that one and then cannot be determined. So
Because it seems like it's best to have 30 observations, but I'm not sure.
yeah, that's true. I don't know.
I don't know. Yeah, I guess on that one, just mark whatever you feel comfortable, I guess.
How about none of them? Okay.
If you have an inclination, Brianna, go for it. If you have
Number
an
6?
inclination. Yeah,
Okay.
just go for it, guys. Cool.
Which
Okay.
of the... Oh, did
Go
you
ahead.
want me to read it?
Oh, if you want to, sure.
Oh, no, you go. I thought it was my turn, sorry.
No, you're good. It's cool. I don't know. All right. Okay. Number 6. Which of the following results implies that the spread in X bar decreases as the sample size increases? Obviously, if it's talking about the sample size increasing and the X bar, so the sample mean being closer to the regular mean, it would have to be the law of large numbers.
Yeah, that's exactly it.
A lot of happy dances today. It's made me feel happy. All right, Brianna, number 7.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and a standard deviation of 8.8. Use the information, of course, to answer the rest. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
Well, let's calculate, shall we?
Okay. Okay.
One.
Okay, let me know what you guys got.
Okay. Almost done.
1.0454.
Yeah, that's what I got. Yeah.
I'm really slow at this, sorry.
Ooh. Yay.
Negative 1.0454.
I got positive, but same numbers.
Say what?
I got positive 1.0454, and I think she had the same one, but negative.
Okay. Yeah, I got the positive as well. Lori, how did you
I
get
wasn't
negative?
sure which number should be first, the ones here, the 158.
Oh, yeah, okay. It would be 160 minus 150.8. No, you're good.
And so it was
Divided-
1.04.
Say what?
0.045, 3 decimal
Oh, yeah.
places.
Okay, yeah. 0.45. Okay. Me too.
You're good. And then as soon as we've done that, Hannah, do you want to read the next question?
Yes. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So how do you work this one out?
I think you just type in the z-score, right? And then do
Yeah.
greater than.
That's
Oh, sorry. Okay. And the z-score was the same one from the previous problem, right?
Mm-hmm. Yeah. That's the one.
So 0.148. Sorry.
I haven't been able to get into the applet, so.
Okay. I got 0.148 as well.
Okay.
Yeah.
Hopefully you guys don't lose access to it.
Yeah, for those who don't have access to the applet, it's 0.148.
Okay.
Okay. Lori, do you want to read number 9?
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores?
Oh, okay.
You have to find the sample mean, and then you find the z-score. Correct?
You just add them up and divide them, right? Am I wrong?
Yes. Uh-huh.
Okay.
Okay. Oh my gosh, that just happened. Someone just tell me if they as well got 1.045. Just out of curiosity.
Well, because you get 160 for the mean, so it's the same as all the other problems, right?
Yeah.
Woo!
That's what I was thinking. I was like, that is so funny.
Sometimes they do that.
Say what?
Sometimes they have repeat answers.
Yeah, try and trick you a little bit.
Yeah. Tricky. All right. So after we've written that down, I'll read number 10. And it's, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. Example. No, we already read that.
Is that the same answer as number 8?
I actually am really thinking that is the answer. Yeah, probably.
Okay.
Because it's saying greater than, right?
Right.
What the heck? Yep. 0.148, guys.
All right.
Oh, so funny. Okay. And then, let's see, who am I switching to? Okay, Brianna. Number 11.
11. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the that's what it means by x bar. The sample mean of the 81 students who are selected. Approximately normal, yeah.
I say approximately normal.
Okay.
Because even though it says left skewed, there's a sample of 81 students.
Uh-huh.
Yeah, so it's larger than 30.
Ooh.
All right, Hannah, do you want to do 12?
Okay. What is the mean of the distribution of the sample means for all possible samples of size A1 drawn from the parent population? So isn't that 3.5?
Yeah, that's what I think.
Okay. Yeah, sounds good.
All right. And then for number 13, Lori, if you want to read that one.
What is the standard deviation of the sampling distribution of the random variable x bar, the mean of 81 students who are selected?
Yeah.
The sampling distribution. Can't even think of it. Is that
So,
just
so is that new formula that we learned?
yeah. Well, I don't know.
It would be the standard deviation of the population divided by the square root of the number of samples,
Okay, yeah.
I think.
And our standard deviation is
So it'll be 0.7 divided by 9. Is 9 times 9 81?
Yes. Because 81, the square root of 81
Is 9,
I
right?
do that. Okay. Yeah. So, Lori, what did you get for that one? If you're done, sorry, you're not done.
I'm not done with that one.
Okay.
I'm kind of lost on that one. Okay, we ended up like 3.5. I'm not even sure how to set it up.
So you
That's
go.
Deviation is 0.7, and then because we have a sample size of 81 students, it's 0.7 over the square root of n, and n is 81.
Okay, and that's it?
Yeah.
Yeah.
So 0.7. Square root of 81 is 9.
Mm-hmm.
0.7 divided by 9 is 0.0777.
Yeah. Yep. And I just rounded it to 0.078.
Good one. Okay.
Perfect. Okay. Next one. Number 14. What is the probability that the mean GPA for 81 randomly selected BYU-I students will be less than 3.3? So. Okay. Okay. For the Z-score, did you guys get -2 0.564.
Let me see. And so you divide it by. So I'm having like a really bad brain fart. So you would subtract 3.5 or 3.3 from 3.5, right? And you get negative 0.2.
Yes.
Is that how far you got? Or is that how far?
Yeah. So then.
And then you divide it by 0.7?
You divide it by the standard deviation of the sample that you found in the previous problem. So you divide it by 0.078.
Okay, that makes more sense.
Yeah.
Yeah, that's what I got then too.
Yeah.
So what was your z-score again?
Mine? It was negative 2.564.
I got negative 2.571. I don't know. I probably did it wrong.
Let me see.
2 divided by 0.07.
Oh, did you, Hannah, did you, like do 3.3 minus 3.5 divided by 0.7 divided by the square root of 88, and you just did that in full?
Is it 88 or 81?
Or
Maybe
81.
that's where I missed it.
Sorry. 81.
Yeah, that's how I set it up. Is that wrong?
Okay, because you probably, since I rounded, since the last question, we rounded the answer to 0.078 instead of 0.07777 continuing. That's why you probably got like a slightly different answer than what I got.
Okay, so it needs to be 0.78.
Well, I mean, either way, it's like we'll still be getting a generally close estimate of what it is and just kind of round it based on that. So.
Did you guys get 2.574?
Something
I think
relative.
that's what
Yeah.
Hannah got.
That's what I got. Is that right?
I think probably about
got, like-
right.
Yeah, that's cool. I can double check mine. Give me one sec. There.
The probability. So you need to come up with a percentage.
7. Okay. Lori, I will go with your answer. So I got negative, when I didn't round anything, I got negative 2.571. And that's what you got, right, Lori?
I got positive 2.574.
74.
I got the negative 2.5714.
Okay.
But we need the probability, so does that mean we need to use an applet?
Yep, I can do that. Point. Okay, so it would be 0.005.
That's what I
The
got.
decimal that you put.
0.005 because it's less than.
Yep. Perfect.
0.005.
And then Brianna, do you want to do number 15 after you've written that one down?
Okay.
Yeah.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 0.3? So.
Okay. So then take 0.005 minus it from 1.
.995.
Perfect. That's what I got too.
Okay. Got that.
Okay. Do we all feel comfortable with submitting our answers then?
Yeah.
Darn it.
What
Did we miss that one?
Oh, snap. What do I do?
9 and 10.
What do we do?
Oh yeah, I missed 9 and 10 too.
What happened?
No idea.
We must have gotten too excited that they were like the same answers.
Dang it.
But
Man,
wait,
that was a rough one.
we did all get like 160, right, for that?
Let me.
9
Divided by 5 equals 160, yeah.
I'm probably
Yeah,
gonna
so I
put
think
it
we
in
did
all
it right.
ones.
I think so too. Or, well, when we post our video too, we can, like, put a comment in there maybe.
Yeah.
Yeah, that's a good idea.
Okay. Okay. Well, I know that he says on the group collaboration thing not to discuss the quiz at all, so I'll do it in like an email to him. Yeah. Do
Okay.
it that way. That's a poop dump. That was.
I know.
that
It's
way.
okay. We tried our best.
All right.
All right, so are we meeting next week, same time?
Now let's do the same time. 5 on Monday, 5 on Wednesday. Does that work for everyone still?
Yeah, that works.
Yeah, that works.
Perfect.
All right.
Bye,
Yeah, let's
guys.
do that. Okay.
Yeah.
Bye.
I see you.